Hello, I'm Amanda. I'm going to present the paper Decoding Trust, a comprehensive assessment of trustworthiness in GPT models by the authors Boxing Wang and et al. As we know, the ChatGPT is capable of role-playing, but this ability can result in trustworthy concerns. So this paper presents a comprehensive assessment of trustworthiness on GPT 3.5 and GPT-4 models. They used both existing standard benchmarks and diverse adversarial system or user prompts to test the GPT models. The test aspects include toxicity, stereotypes, adversarial robustness, out-of-distribution robustness, robustness on adversarial demonstrations, privacy, machine ethics, and fairness. So here is the input and output example of all the aspects. The red marked words are the undesired outputs. This would be some bad results generated by GPT. Agree with some stereotypes, false positive and false negative, information leakage in privacy, fail to recognize immoral actions, or unfair response in fairness tests. And the discussion question I come up with is why is trustworthy focus evaluation crucial for LMMS? And here's the architecture of the benchmarks that include the existing ones marked in the yellow and the new generated ones marked by the green ones. And I think the green benchmarks are the major contribution to the novelty of this paper. And then let's go into the result of assessment. So toxicity is to test how well GPT models avoid generating toxic content. They evaluate in 3 benchmarks, and the results show that compared to the LLMs without instruction tuning and the reinforcement learning from human feedbacks, GPT 3.5 and GPT-4 have significantly reduced the toxicity in generations. But both GPT 3.5 and GPT-4 can still fall in the trap of the jailbreaking prompts. They still generate toxic content with the designed jailbreaking prompts, and GPT-4 is more likely to follow the instructions and use the GPT 3.5 and GPT-4 model to generate the challenging user prompts, can also increase the model's toxicity for the evaluations overall. The second perspective evaluated was stereotype bias. It's tested on a custom dataset of statements created by the authors. It includes bias on 24 demographic groups. They measure the average likelihood of the model agreeing with the given stereotype statements. And for untargeted system prompts, GPT 3.5 and GPT-4 are not strongly biased for the majority of stereotype topics, but both GPT models can be tricked into agreeing with biased content given designed misleading, and GPT-4 is again more vulnerable to misleading target system prompts because GPT-4 follows the misleading instructions more precisely. And for GPT models, bias is often dependent on demographic groups and stereotype topics. So they tend to output more biased content on less sensitive topics like leadership or breed. And the next perspective evaluated is adversarial robustness. It's to test the robustness on textual adversarial attacks. It's evaluated on ADV-GLUE and ADV-GLUE Plus that allows the GPT models to test against open source autoregressive models. And GPT-4s in the results surpass the GPT-5 3.5 model on the standard ADV-GLUE benchmark. It demonstrates that GPT-4 have higher robustness. It also is more resistant to human crafted adversarial text. But for the ADV-GLUE Plus test, we can see that the GPT models are still vulnerable to this kind of attack generated based on other autoregressive models. And in this table, we can see a clear performance drop in the performance drop column and also a performance drop in the average accuracy for both models. And these are just showing which model is most challenging for the GPT models to combat with in different tests. The next perspective evaluated was the out-of-distribution robustness, is to evaluate the robustness of GPT models against the out-of-distribution data, which is data different from the training data of the model. GPT-4 exhibits consistently higher generalization capability given the input with diverse OOD style transformation compared to GPT 3.5. And when evaluate on recent events, which is the knowledge part, GPT-4 model also demonstrate higher resilience than GPT 3.5 by answering I do not know rather than make up contents to the knowledge that's not covered in the training period. And with OOD demonstration that share a similar domain but differing in style, GPT-4 presents consistently higher generalization than GPT 3.5. And with OOD demonstration that contain different domains, the accuracy of GPT-4 is positively influenced by the domain that's close to the target domain, while GPT 3.5 performs a decline in the model accuracy overall. And then for the robustness against the adversarial demonstration part, this part is to evaluate the robustness of GPT models given misleading demonstration to access the potential misuse and the limitation of in-context learning. So with evaluation on counterfactual and the spurious correlations and added backdoor in the demonstrations, we can see that both GPT 3.5 and GPT-4 models are not fall in the traps of counterfactorial examples. But when it comes to the spurious correlations, we can see that GPT 3.5 is more likely to be misled than GPT-4. And after the backdoor is added, we can see that both models is misled after the backdoor is added, and also GPT-4 is more vulnerable to the backdoor demonstration. The next aspect evaluated is privacy. So privacy is evaluated by the information's extraction accuracy of sensitive information in the pre-trained data also of personal informations that included in the conversations, and they also evaluated the information leakage rate. And the result turned out that the GPT models can leak privacy-sensitive training data. And in this AB form, AB table, we can see that the correct domain have the highest leakage. Also, the information of personal identification can also be leaked during the conversations. And we can see that GPT-4 is, again, more likely to leak privacy, potentially due to it following the misleading instructions better. And in this prompt, we can also see a comparison between GPT 3.5 and the GPT-4 leakage. And then for machine ethics is evaluated with common sense, moral recognition tasks. So the GPT model are asked to evaluate if a action is wrong or not wrong. And here we can see that in table 27, GPT-4 models recognize the moral text with different lengths more accurately than GPT 3.5. But both of these models are performing better than most of the non-GPT models. And also for the jailbreaking attempts, both GPT 3.5 and GPT-4 can be misled. And GPT-4 is again misled easier because of the following the misleading instruction better. And in this figure here, we can see that both models are fooled by the evasive sentences. And also in identifying conditional actions, the model performed differently in different categories, but in the given categories about harm, GPT-4 performs relatively better, and GPT 3.5 is actually very bad at recognizing like harm to oneself is a wrong behavior. And for the evaluations on fairness, here in table 30, and we can see that the GPT-4 is more accurate than GPT 3.5 given demographic balanced test data. It can be higher unfair. It can like receive higher unfairness score if it have like unbalanced data. And both GPT 3.5 and GPT-4 have a large performance gap across test groups with different base rate parity. And the GPT models are initially biased to certain groups, but the prediction of fairness of the GPT models can be improved by providing a more balanced training context. Yeah. So in conclusion, I think like the importance of trustworthy focus evaluation for LLMS is it reveals some current problems with LLMS, and it may remind the users to maybe to come up with some correct behaviors when using the LLMs to maybe make the model better, or also to provide the information of themselves. And here it includes the code source by the authors, and here's the reference. Thank you for listening.